Hello. I hope you are able to see my screen.
Yes, yes, sir.
Okay, sir. So welcome to week 3 of this problem solving session on data science with our software part 2, where we are learning about sample theory and linear regression analysis. I am Shreya, one of the TAs for this course, and today I'll be discussing majorly week 3 problems. So before moving on, do you have any specific questions, queries that I can answer?
Ma'am, actually, in the last, this assignment number two,
Hmm.
uh, submitted my assignment second.
Hmm.
Two questions were wrong. That if you could recollect that two questions,
Okay.
the about the uh, 75 shops, the preference of 75 shops at fourth floor. I just guess that the all the customers who are coming to the mall, they will be giving preference, but the option were wrong actually. So two of the questions actually went wrong.
So this is question 5 or 6. Can you wait? I'll just stop
Five and
sharing
six. Yes.
and then share the entire window.
Yes.
Hmm. So, what was the question? A seven-story shopping mall has 75 shops on each floor. Owner
Yes.
of the shopping mall wants to know the preference of the customers for the shops on the fourth floor through a sample survey. The sampling unit in this case is customers visiting the fourth floor of the mall. So, what is
Yes.
the confusion over here?
Actually, I mistakenly I just opted that uh, I was having both the answers. Initially, I had the answer that the customers visiting the fourth floor, they
Hmm.
will be giving the preferences for the 75 source. But I later on I decided against this, and I just opted that every customer visiting the mall, they will be opting for the preferences. Both the questions have gone wrong. Otherwise, everything is right. As a first and second assignment.
So 5 and 6, so you you were thinking about any shopkeeper.
No, 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 no.
Then
This customer visiting the shopping mall, the third
the
one.
third one, customer
Yes,
visiting the shop. Acha, any customer visiting the shopping mall.
yes, yes.
And
Overall, yes.
overall, you were thinking about this. See, I'll tell you one thing. Your answer is not wrong. Okay,
Okay.
it is a very probable. Uh, what do I say, sampling unit. Any customer
Sampling.
visiting the mall can give a survey of the fourth floor. But the
Yes,
problem is, if that customer is not going to the fourth floor to, I mean, that customer will not enter any of the shops in the fourth floor. So in that
yes,
case it will, if let's say you have thousands of customers, or let's say 500 customers visiting the shopping mall, and you
yes,
sample all 500 of them, but hardly 10 of them is going up to the fourth floor mall. So,
yes,
if you have that kind of a sampling unit, then the problem that you would encounter is that a lot of people, since they won't go up to the fourth floor, you will have a lot of no response. So, that will
yes.
generate a non response bias in your data. So
Exactly.
in order to circumvent that problem, if you just, I mean, if you want, if you localize your sampling unit to the customers who are only visiting the fourth floor,
Fourth.
then you will have a lot more responses, and probably the responses will be accurate, more accurate. And because you are sampling only I mean, you need information on only that floor, so that uh, customers visiting up to, I mean, customers visiting the fourth floor will be a good
Sampling,
representative sampling.
representative sampling.
Yes, this is not
Later on,
wrong.
excuse me, sorry, ma'am,
Yes, yes.
I just interrupted you.
No, that's okay.
Later again, I reviewed my assignment. Then I
Hmm.
found that yes, the question was, when I reviewed the question, no, the customer's preference for the fourth floor shops instead of the all the shops. Yes,
Exactly.
exactly.
Exactly. So this was the key point.
Key point. Yes, ma'am.
Preference of customers for the fourth floor. You could sample for any customer visiting the shopping mall, but it would be more appropriate to go
Appropriate.
and sample the fourth floor customers.
Yes.
Similarly, I don't know it if let's say this would have been ground floor, then also it. I mean, usually people, if they don't have very targeted locations to go to, usually people go around in ground floors. So in that
Ground.
case also probably that any customer visiting the mall would have been a good answer. But if we just restrict it to customers visiting the ground floor, then that would be a better sampling unit, I feel.
Sampling.
Okay, and in this
Well,
question number 6, the seven-story shopping mall has 75 shops on each of the floor. Preference of customers.
sampling frame it was asked.
Oh, okay, this is the sampling frame. Sampling frame would be all customers visiting fourth floor.
Yes,
Yes,
ma'am.
all right. The other questions were okay.
All remaining first and second assignment other questions were right.
All right.
Only these two questions went wrong.
Okay, okay, good. So, before moving on to week 3, I will like to solve a few more week 2 related MCQs. I hope that will
Yes.
help. So, should I review problems similar to this? What I discussed in the last week? Would you want
Yes,
that?
yes, you may please.
Okay. So, so all right. I'll quickly skim through whatever I discussed in week 2. Just give me a minute. I'll just put it on silent. So this was the question. Which of the following is the primary advantage of using a sample survey? So it is typically more, out of these four answers, this one suits it the best. It's
So most
typically the
cost
others are
effective,
wrong actually, because census is not faster even though it provides more accurate results, and sample
small time
survey
consuming.
doesn't. Sorry, you were saying something?
Census is time consuming because
Yes,
complete population is
complete
to be surveyed.
enumeration is required. Yes, so it's both time and cost
Yes,
heavy. And sample survey doesn't collect information from every member,
yes.
and since census will not have any sort of sampling, so there's no question of sampling error. So the correct answer was B.
B,
Then
that is sample. Yes,
that it is more cost effective and time
cost
efficient.
effective and time efficient.
Question number 2 was, what is the primary goal of a sample survey? So this is the most appropriate one.
Based on subset.
Yes, because sample survey will not collect data, that would be a census, and every sample survey will have some sort of sampling error. You can't, in all practical situations, so you can't just do away with sampling error. Okay, so which type of error is introduced when a sample does not accurately represent the population? It is sampling error. So that question of yours, if we just sample all the people who are visiting the mall, that will result in larger sampling errors.
Larger sampling. Yes.
Okay. The next one was this one. So in a survey, stratified sampling is used to, this is the correct answer, divide the population into subgroups and select randomly from each subgroup. We are going to learn about this in subsequent
Yes.
classes, but this is just a brief. Uh, what is a key feature of cluster sampling? It's the same thing, similar. You stratify it into groups
Stratified.
and then you select entire groups, not from within groups. So in stratified sampling, what
The entire
happens?
group is selected in this.
Yes. So in stratified sampling, you categorize and then select samples from each of the categories. But in case of cluster sampling, you just cluster, make it into groups, and then select one group at random. All individuals that fall in that group will come in your sample. Okay.
Right.
The next one is, why would a company use a sample to conduct a market research survey? To reduce cost and time.
Cost and time spent.
So this is the correct answer out of all of these. There could be other reasons as well. Okay. So which of the following is an example of a situation where stratified sampling would be preferred?
Age groups about Indian product. Situation where stratified sampling would be preferred. Different age group, because they will create stratas of the ages.
Yes. Okay. This one is, which of the following best describes primary data? So primary data is data that is collected first hand. All
First
other
time.
data sources are secondary data sources. So if an experimenter is going and doing hands-on data collection for the first time, that data is only primary data. Suppose you go and visit a field and get some health data, for example. Now for you it's a primary data, and you
Yes.
are working with that, you're storing it, and then you're making that data available for public. So when public is using that same data, that for the public it would be secondary data.
Secondary data.
Yes. uh, so all these government health reports on obesity rates, these are all secondary data for us, because some other people have collected it and they have performed some sort of, we don't know what exactly has gone into, because whenever a sampling happens, it is a massive work, even with small health surveys, let's say, because you have to go and target various regions of the population. There is a lot of manual labor involved. During sample collection, you would typically design a questionnaire or something, and then or carry out experiments on to collect some sort of data. Let's say you collect blood from each of the person, so there could be errors introduced at each of these states. Okay.
Right.
There could be tabulating error as well. Let's say you have appointed a personnel to get the population characteristics. Let's say you some one person is collecting um, family information, let's say your age, gender, and everything else, and then another person is also collecting your age, gender, and some health related data that
Data.
the survey is about. Okay. Now it is very well possible that while entering into the system, or if you are doing manually, the person A who is collecting demographic data, he reports a certain kind of a age, and then another person, he or she, that person is reporting a different kind of age. So when these sort of data is made public, you a lot of data cleaning goes into, a lot of data cleaning is done before any sort of data is made available to the public. It could be open source, it could be paid, but anyhow, all sorts of sample surveys or secondary data go through these kind of intricate steps, and some steps which we are not aware of also. Maybe I have some data on cancer patients. Okay, so I my goal is, my research area is, let's say, cancer. You want some data on some particular variable that I've collected, but you don't know that my interest was cancer, so I've sampled from cancer, majorly from cancer patients. So you as an experimenter, you would want more control over your data. So what are those advantages of using primary sampling? Because you would be aware of the assumptions that go into the data, that collection technique. I may decide to do stratified sampling, but you may feel that, okay, since uh, I am targeting a certain type of cancer, I will do cluster sampling, something like that. So those sort of intuitions, or you could say assumptions, are not always very well established and very well available openly. So if you want to gain more control over your data, then that is one of the advantages of using a primary data. But secondary data is, of course, is faster and cheaper. Okay.
Okay.
And this question, it says, it is always more accurate than primary data. This accuracy is a question mark, because are you talking in terms of uh, collection and data integrity? It could be that. But are you asking in terms of accuracy, in terms of representativeness? We don't know. So we can't say that it's more accurate than primary data. Yes, primary data will have some issues, but those can be fixed to a certain extent. So you can make primary data and tailor it more to your convenience and need, but it's not, definitely not correct to say that secondary data is always more accurate than primary data. Okay. The
Yes.
next question is also similar. Why might a researcher prefer to use primary data over secondary data? Because it is collected for a specific purpose, ensuring it is more relevant and reliable. It's not always unbiased, not cheaper, and it is definitely easier to find and analyze. But the more pressing point is this: it's collected for a specific purpose in mind. Okay.
Yes.
This one. If a researcher is conducting a study on public transportation usage, which of the following would be a sampling unit? So, somebody who's using that public transportation would be the preferred sampling unit. So, in this case, the individual bus rider. Then, this one, in a study of air quality in urban areas, which would be considered as a sampling unit? So, since the focus is only on urban areas, I feel that it is more appropriate to collect measurements from specific monitoring stations, and stationed in the urban areas. So, for me, B is the more correct answer. And not the number of vehicles in the city, because there could be other sources of pollution as well. And government's environmental department, they will not, um, that will not work as a sampling unit. Okay, this one, if we are interested in studying the relationship between air pollution and asthma in urban areas, who what would be the sampling unit? So someone who's experiencing pollution and also having asthma. So then this one is the more appropriate answer. Question 15. In a study of effectiveness of the drug, what will be the sampling unit? Of course, the individual participants in the trial. Which sampling method is most likely to lead to a representative sample in a study about general health of adults in a country? So, since it's general health, a random sampling from a national registry would work fine because that would represent uh, all the individuals who are living in the country. Of course, we could do a convenience sampling, but that will be less representative. Uh, this one, in a survey on public opinion about a proposed law which would help achieve representativeness. So, serving people from a random sample of various age groups and socioeconomic backgrounds, I feel, is an appropriate answer because whenever a law is proposed, it is going to affect all the people. It's not going to affect only political experts or people who uh, have expressed their views online or somebody living in a certain area. So that is why serving people from various age groups and socioeconomic backgrounds would be more appropriate. Okay, question 18. A survey is conducted to determine average number of hours college students spend on social media per week. And that is the question, average number of hours college students spend. And sample is taken from one prestigious university in an urban area. So this would make the sample a little biased towards students from urban areas and prestigious universities. Since my question is pertaining to college students, not college students in urban area from prestigious universities, but in general college students, making a very specific sampling unit or sampling frame would lead to biases. And what is a sampling frame? It's a list of all possible individuals or units that could be surveyed. And what is the key difference between a sampling frame and a population? So population includes all elements studying, and sampling frame is a subset of the population that is used for some sampling. Okay. All right. Now I'll move on to 5 more questions which are a little trickier, and then we'll get started on week 3. Okay. So about this one, a researcher designs a survey to measure public opinion on a controversial policy. The sampling frame consists of individuals who have signed a petition related to the policy. Which of the following is the most significant limitation of this sampling frame?
Sampling frame consists of individuals who have signed the petition related to the policy. Excludes individuals who disagree with the policy but have not signed. C1, ma'am, it represents individuals who are
Yes.
policy.
So
C,
I feel C is the most appropriate one because uh, public opinion on a controversial policy, people may have an opinion but may not have signed the petition. So those individuals are excluded. Option
these are
A
the
is also somewhat correct. It ensures that only individuals But this is uh,
Yes, that's first.
that
Only
is
this thing
also,
happens.
I mean, that could be a possible answer, but for me the more worrying is it's not representative of some people who do have an opinion but have not signed the petition. Okay.
The public opinion on a controversial policy. Yes, ma'am.
Okay.
The sampling frame consists of individuals who sign petition related to the policy. Most significant limitation of the sampling frame. Yes, ma'am.
Okay, all of these except D, all of A, B, and C seem to be more or less correct to me, but out of these three, C I feel is more appropriate. Okay, question 22. A study aims to understand the financial habits of high income individuals. The researcher decides to use a list of individuals who subscribe to a premium credit card service as the sampling frame. What is the major flaw of this approach? It may overrepresent individuals with financial knowledge and expertise, may exclude individuals who are healthy but do not who are wealthy but do not subscribe to premium credit cards. It may include individuals who are not wealthy but use premium credit cards for rewards, and it will include younger individuals who may have different financial habits.
Study aims to understand the financial habits of high income individuals. Such as decides to use a list of individuals who subscribe to a credit card service as a sampling frame. Okay. It may include individuals who are not wealthy but use premium cards. It may exclude individuals who are wealthy but do not subscribe to the premium card. Maybe Bravo B man exclude.
Yes, even I feel uh, B seems more correct in this case, because I want opinion on people who subscribe to premium cards.
Yes.
Sorry, I want uh, what is happening? Okay, so because I do want high income individuals. So if I leave out these people who are wealthy but do not subscribe to premium credit cards, my data set will be a little skewed.
Yes.
Yes. Uh, this one.
Citizens who in a study of substance abuse. Citizens need to boys and husbands with likely similar experience with this. A study of substance abuse researchers initially interviewed a few participants and then asked them to refer this to similar likelihood non-response bias as participants are already engaged. It shows the participants are randomly selected in the population at volunteers.
So this is
The
not
same
true. Option B. It does not
B is not.
ensure. B is not true because it's working on referrals. So B is absolutely not true.
Yes. Lead to bias and participants will likely refer people who have similar experience to theirs. Maybe AMM, whose
Yes,
primary
A
concern.
is the most appropriate one, because it is not commonplace to suffer from substance abuse. So it does not guarantee that the sample will be representative of the population.
Hmm.
There seems to be some problem with my pen here. Okay. And reduces the likelihood of non-response bias as participants are already engaged. No, we cannot say this for sure.
Hmm.
So this one is the correct answer, option A. All right, moving on. In a research study, if the researcher uses a sampling frame that includes only certain areas of a city, this may lead to, so this will lead to a selection bias.
Selection bias. अच्छा. Okay.
Oh, what is happening? Just give me some time to fix this. Why is this not happening?
It is not. It is not having thick ASI.
No, I'm not able to. Oh, okay. Now it's
Yeah. No.
working.
It's,
Yes. All right. This one. Which of the following is most likely to result in response bias while collecting survey data? Asking clear neutral questions, giving participants a chance to skip they don't want to questions that they don't want to answer, providing a don't know option for each question, using a leading question to frame an issue in a particular way.
giving participants chance to skip questions they don't want to answer. Using a leading question to frame an issue. Asking clear neutral question, that will be, it cannot be the response bias.
No, this will actually reduce response bias. So this is not the correct answer.
Giving participants a chance to skip questions. So in the response has to be to a question. Result to response bias. Response bias mean
So response bias means differential preference to certain answers.
to certain, okay. Giving don't know option about each question. Using a leading question to frame an issue in a particular way. For me, I think giving skip question,
Okay.
participants a chance to skip questions.
But I feel if you give participants chance to skip questions they don't want to answer, they'll just skip.
They'll skip, but that will not be a
But
bias.
that will not introduce
That
bias
will
in
not be a
your
bias. No,
data.
not be a bias. Providing
Similarly
a
from
don't
this one, if you don't want to answer, you don't want to answer.
don't know. Yes,
You don't know. But if you
yes,
frame a certain question, use some sort of a leading question to frame. For me, this is the correct answer because
yes, yes, yes.
I would
Definitely,
be tricked
this will
into
be.
thinking what the
Hmm.
interviewer thinks.
Yes,
So if it's not, I mean, the questions should be unbiased, I feel,
unbiased.
for my original opinion to come out. But if
Yes,
the question itself is framed in a certain way and it's a little colored towards a certain angle, let's say,
yes.
I would
The
be
question.
tricked or I would be more inclined to answer in a particular way. So
Yes.
that would introduce a bias in my response. It will not be an unbiased thing.
Hmm.
I would be more uh, prompted, or in a sense more willing to answer something rather than
Mm.
something else, if the questions are not, if the questions are a little, tricky.
Mm.
So I feel this is going to
Typically.
introduce more response bias.
Mm. Yes, ma'am. That's right.
Okay, so yes, now I'm going to move on to week 3 and whatever we discussed. So before that, I think my system is running out of charge. I'll just put it on charge. Just give me a second.
Overall, how many participants are in this course, ma'am?
The number of participants enrolled, when I was enrolling, I saw it, but now I cannot see. Maybe once when someone joins the course, they are able to see how many person are enrolled. I'm not sure actually how
Right,
many
ma'am.
are taking
Right, sure.
this. Just give me a second. All right. Oh no. Okay. All right. So I'll just move on to week 3. So in week 3, we discussed simple random sampling, and simple random sampling is a probabilistic technique where we can sample with replacement or without replacement. So
Yes.
what do I mean by with replacement and without replacement? So let's say I have a certain number of uh, let's say I am playing uh, a certain game where I have alphabets here, A, B, C, D, E, F, something like this. And you also have a sheet. It's similar to Housey. I don't know if you have played that. You, let's say,
Okay.
have a sheet which has all these A, B, C, D's characters, some in cross table where you have A, B, B, C, or something like that. So participant 1 has a card like this, participant 2 has a card like this, participant 3 has a card like this, similarly. And I, as the host of the game, let's say, I pick out a number, call it, and then whoever has that particular number
Mm.
is striking that letter off their cards. Let's say this is the game setup. So what I'm essentially, and then whoever finishes first wins the game. Let's say this is a certain type of game that I've devised or designed. So what happens is that I am essentially doing, I have a pool of units over here. I am
Yes.
collecting, sampling from this pool, reading it, and then giving it back to the same pool that I have sampled from. So this
I
technique
see.
is actually simple random sampling but with replacement.
With replacement.
Okay, this is simple random sampling with replacement. Now if I perform the same thing, I am the same experimental setup, and if it is ensured that everyone has a different number, let's say 101, 102, 103, something like this, you could have 103, 104, and I could have numbers. So let's say you have boxes, 200 boxes, every individual has 200 box, and then I am sampling from, let's say, 1 to 5000 or something like this. Okay, so here what I'm doing, I am just calling out a number, a particular number, and then once it is called out, I am just discarding that number and then
Okay.
taking from the remaining. So this sort of a sampling scheme, if I employ, this is actually simple random sampling without replacement.
Understood.
Okay, so in any of these cases, uh, probability of selecting one unit is actually 1 by capital N. So this was also proved in the lectures, but let's say I am what is simple random sampling? In simple random sampling, I am providing equal probability
For every sample.
to each
Each
sampling unit, not sample, each sampling
sampling.
unit. Okay, even if I draw doesn't matter how I draw the sample, I am assigning equal probability to each sampling unit. So when I do that with replacement, okay, so let's say I am carrying out an experiment with 20 trials. So probability of a particular unit, let's say U1, so if this is my population, let's say U1 UN, or rather if I consider this as small u1, small u2, small un, if this is my sampling frame and I assign equal probability, so if I have n samples, I assign probability 1 by n, 1 by n, 1 by n. So up till here I have my simple random sampling. Okay, now comes the question of with replacement or without replacement. So with replacement, what I am doing, whenever I am talking about any with replacement or without replacement scheme, that is when I am not only sampling one unit, but I am sampling greater than one unit. Let's say this is the usual uh, what do I say, background or motivation. Okay, because if I don't do repeated sampling, it doesn't matter whether I'm taking, I mean, if I am only interested in selecting a sample, so doesn't matter whether I replace it or I don't replace it, because I'm not going further. So typically, I mean, there could be questions where you are you could be tricked into thinking something else, but this is the main concept, that whenever I am talking about sampling schemes, I would be interested in sampling a handful, not only one. So in that case, I have to do, I have to repeat this sampling experiment. So in that case, how am I repeating matters. Am I repeating it with replacement or am I repeating it without replacement? So what happens when I have a with replacement technique? So at trial 1, or let's say sample 1, when I am selecting, my sampling frame remains this. Okay, When I'm conducting trial 2, since I have given back to the sample, my sampling frame remains unchanged. Similarly, while I am taking, I would not say trial, I would say select sample unit 1. Okay, select sample unit 2, select sample unit 3, whenever I am doing. So my sampling frame remains unchanged. So at each step, probability of selecting any of the units remains 1 by n. Okay, so if I select u1 in the at first, then it remains 1 by n. If I select u2 at the second step, then also probability remains 1 by n. So at each of these steps, each of the units would have 1 by n probability, because I am assigning equal probabilities. But when we move on to a without replacement case, then when I am selecting sample 1, or I would not say sample 1, I would say unit 1, my sampling frame remains u1 to un. So I have assigned probabilities equally. Whenever I am proceeding to selecting unit 2, suppose I have selected 1, let's say I have selected a unit k typically. So whenever I am selecting unit 2, my sampling frame would then become u1, uk minus 1, uk plus 1, and then un. So in total now I have n minus 1 elements. So if I have to provide equal probability, then for selecting unit 2, I have to assign this probability to each of these units. Okay, but mind you, if a question comes like this, what is the probability of selecting one unit where there's no mention of any trial? So it's the same between SRSWR and SRSWR. But whenever this sort of repeating comes, where I'm selecting more than one units, so the number of units I select is actually my sample size. Okay, number of units selected, I should write, is actually my sample size. So whenever sample size is more than 1, that is the time we should be more concerned about the type of probability schemes that we are addressing. But typically if somebody asks that, let's say I have 20 individuals in a population, what is the probability of sampling a person A without replacement, and that's it. This is all the information that you need. So that would be 1 by 20, as simple as that. Okay, but then if somebody says that what is the probability that we select B and then we select A, or something like that, or something similar, then we have to see how we are, the experiment has been carried out, and then accordingly draw the probabilities. So
without replacement and with replacement concept, I have to see.
yes, without replacement and with. So I'll solve a few problems which I hope will help answer the assignment questions. Okay.
Right.
So before that, so probability of drawing a unit is 1 by n and 1 by m. So this is the same thing, probability of drawing a sample of n units. So when I'm talking of sample of n units, so come here, this is with replacement. So I am selecting one from here Okay, that probability is 1 by n. 1 from the second time, that probability is 1 by n. And then 1 from here, that probability is also 1 by n. So probability of selecting a sample, a particular sample, is actually 1 by n whole to the power n.
This is probability for selecting
This is probability of selecting a
n
sample
units.
of size n. That is n number of, selecting a sample of size n. So if I have to select n units, let's say, and that would comprise of that sample, then the probability will be 1 by n to the power n. Okay, or in other, if it is easier, let's say I have n blank spaces. Okay, so I am trying to decide all possible samples. Okay, so in
Yes.
this place I could have either of the n units. In this place also I could have either of the n units. In this place I could have either of the n units. Similarly, at the nth place I could have either of the n units. So total number of possible samples is actually n into n into n into n times. So all possible samples is actually n to the power n. And out of all possible sample, I am just selecting 1. So then my probability becomes 1 by n to the power n.
Hmm. Ma'am, slightly go back on slide 10. Kindly repeat from here. Yeah.
Which particular section do you?
Yes. Slide 11. Yeah, from after this equal probability to each sampling units. Here is this is in case of with replacement.
Yes,
This
this
is
is
1/n. That
actually,
is okay.
this is okay. No, this is
Now,
simple random sampling
yes, ma'am.
where we assign equal probabilities. So
Quality
this one is
to each
actually
sample.
equal probability assignment. That is the main purview
To
of
each sample.
simple random sampling. Then we move on to with replacement, where I am assigning equal probabilities to my set,
Unit 1.
to unit 1. Yes. So each of the units will have 1 by n probability throughout, no matter how many times you sample, because we are giving it back to the thing. Now the next is probability. This is probability of selecting a unit, and this is probability of selecting a sample. So a sample consists of n small n units, let's say. So if I am doing a simple random sampling, I want, out of all possible samples that is actually possible, I want 1. I'm selecting only 1, let's say,
1.
a typical sample. So
I
I'll
mean,
just,
these are n samples.
no, this is
These are
n
yes,
is the sample size, so n units.
n units. Okay.
Yes.
N units does mean that the population contains n units,
No, population contains capital N units.
capital N units.
Yes. So population has capital N units, and my
Okay.
sample should contain small n units.
Okay. Sample should contain small. Yes,
Okay,
that is.
so I have n small n blank spaces to fill, and
Mm,
these spaces, n units are containing for this space, the same n units are also containing for this space, same n units are also competing for this space. So in total I would have n into capital N into n into n into n small n times. So I could have that many number of samples.
mm,
Just a brief, let's say I have 2, okay, and I have
mm,
1 2 3, okay. So
mm.
how many possible I could have? I could have 1 2,
2,
I
3,
could have 1 1,
1, 1.
I could
Yes.
have 1 3, okay. I could have 2 3, I could have
Mm,
2 2, I could have 3 3,
mm.
okay. 1 2 1 1 1 3 2 2 2 3, and I could have 3 3. Any other thing that I'm missing?
I think 2, 2 is also there. 3, 3 is there. 2, 3.
So it could, I
So,
could also have 2 1, no?
mm, 2, 1. Okay. So, changing the place is also unique, I think.
No,
Unique
1
sample.
2 and 2 1 is not unique, let's say.
Not unique.
It's the same thing, let's say, from a sample
Same.
perspective.
Mm,
So what I am doing is actually 1 2 3 4 5 6, another 2 should be there.
okay. 1, 3. 1 1 2 2 3 3 has come. 1 2 1 1 3 1 1 2
Okay, so 2
2.
1 is also there, 2 1 2 2 2 3, and 3 1 3
Okay.
2 3 3.
Mm.
Uh,
One one has also come. 2 1 has come. 3 1 3 2 3 3 has already come. 2 2 2 3 3 1 1. Who has come? 1 3 1 2.
so this is the total number of, uh, right now we are not talking about ordered or not ordered, okay, we are just talking about how to
Actually, I think
populate this
9.
space. So
Total
you'll
9
see total
samples.
9 I mean, there are total 9 ways I could select this sample,
Yes, ma'am.
okay. And then I am selecting, let's say, 1 3, so my
Hmm.
probability will be 1 by 9.
This is a sample unit.
So these individuals are sample units.
Okay.
Okay, I'll just highlight it with a different color. So this one, these blanks, again I made some mistake, wait. So these individual greens are units, okay, and
Hmm.
this purple box that I am taking, this is my sample,
Hmm.
and the size of
So
this sample,
those are sample units.
and size is 2.
Okay. Size is 2. Unit is the single individual and sample unit. Sample size is 2. Hmm.
Sample size is actually number of units
In a sample
in the
unit.
sample.
In the sample. Okay.
That is actually your sample size. So let's say you have 10 uh, brands
Mm.
related to some fast food, and you want to choose 3. You want to have a sample of 3.
Mm.
So then 3 is actually your sample
Sample
size.
size.
Okay.
Mm.
So this was about probability of selecting a sample of size small n from capital N units. Now if I want to do the same thing without replacement,
Mm.
so what I'm essentially doing is, if I'm going with the without replacement scheme, I have n spaces which I need to fill up.
Mm.
Okay. Now for the first place, and I have n units. Okay. So
Mm.
for the first place, I have n choices, capital N choices. Okay. For the second
Mm.
place, I have n minus 1 choices. For this one, I have n minus 2 choice. Okay. So if we go
Mm.
similarly, we'll have 1 by n into 1 by n minus 1 into 1 minus n minus 1 by
Small n. Mm.
this thing. Okay. So this would
Mm.
be, if I can, so if I can write it as this, okay, and then
Mm.
uh, these individuals could, I mean, these things could arrange themselves in, uh, let's say, n factorial number of ways.
Mm.
So essentially, I would have 1 by NCN. Okay. So
Mm.
this is a little more confusing, I believe, to understand, but
Mm.
uh, I would ask you to remember this sort of a scheme. This helps to solve questions, but for the proof of why it's NCN 1 by NCN, you can, I think, look up this document where they have provided the proof. Probability of selection of a sample. So there are n units. Probability of selection is P1 to Pn. First unit
Mm.
is selected, then there are n units left to be selected. Oh, okay. So, so in this place, so first unit is to be selected, then there are small n units left to be selected from the population of capital N units. So that would be, so here what I'm talking about is actually 1 by NCN is the all possible choices. But I think this is an easier way to understand that. First, for the first one, I am just selecting small n units. I could select any of the small n units out of capital N units. For the second trial, I am selecting n minus 1 out of capital N minus 1. So when the third unit is selected, then out of the small n minus 2 unit, I mean n minus 2 units are left to be selected from a population of n minus 2. So if we just go on, this is going to give us 1 by n choose n. Okay, and what I explained is this thing. So if let's say I have 2 units and I have 1 2 3. Okay, so in I could select 1 2
Mm.
1 3.
1 1 2 1.
No, this is without replacement.
Okay, it's without replacement. Okay,
Yes,
huh? 1 2 1 3.
and then 2 3.
Need two. Acha, 1 2 1 2 2 3. 1. 1 2. Once we have selected the unit,
Yeah, this is the all possible uh, units that is possible. So this is the total number of, I mean, this is actually a set of all possible samples that we could have.
mm,
And from here, I am selecting 1. So it would be 1 by 3. Because in this case, 3C2 is actually 3. So whenever I am talking in with respect to with replacement sampling in a broad sense, this we should consider as, um, I mean, whatever I have, I mean, 1 2 and 2 1 should be different.
Hmm.
Okay, but typically when I'm talking in terms of without replacement, I am also
Hmm.
concerned about the order. Okay, so let me just move on. That will help understand and solve problems better. So, in simple random sampling without replacement, following is a key characteristic. Without replacement.
Each sample drawn is dependent on the previous sample. Without replacement may with replacement without replacement it is not dependent. Without replacement,
Oh, this should be WOR.
this is without WR. Yes. Each sample drawn is dependent on the previous sample. The probability of selection of each item change as the sampling progresses. Hmm. Without replacement. Without replacement, so the here the probability will remain same for every unit.
Without, it'll not, I mean,
Without without replacement will change, na? It will keep on changing.
without replacement,
Without
uh,
replacement means the size
probability
of
of
the
selection
population.
changes as the sampling progresses. Yes,
Yes,
this is true.
the probability of selection for each item changes as the sampling progresses. The sample size is fixed. No sample size sample and each unit can only be selected once. Acha, which of the following is a key characteristic? Replacement occurs after every selection. The replacement is not occurring here. Here it's no replacement.
Hmm.
Selection for each item changes as the sampling progresses. The sample size is fixed and each unit can only be selected once. Yeah, that is this.
So, most appropriate one is C,
Hmm.
and then probability of selection of each sampling also changes as the sampling progresses of each item. That's true
Hmm.
because we are sort of sampling from,
But ma'am, yesterday I attended the class. I've gone through the video of Salab sir, in which he was talking that in both the cases the chances of selection for in both the SWR, the WR and WR remains same. That is one by n.
yes, but That is what I was telling. If you just consider one chance, it remains same.
Okay, one chance.
Okay,
Okay,
so
if it
you,
subsequently if it is continued.
if it is said that a sampling is carried out from 20 individuals, and what is the probability of selecting individual A with replacement or
Is
without
1/20.
replacement? That is 1 by 20. That remains same. But if
Okay.
you have questions framed in this manner, where you need to think when this sample is getting selected, at
Hmm.
that point the probability is going to change.
Hmm.
Okay, depending on what else you have. So that is true. Typically, if I just say probability of selecting a sample of not selecting a sample, selecting a unit without replacement from a pool, it's 1 by n,
Hmm.
goes without
Hmm.
saying. But if I say that what is the probability that I am selecting uh, B and A or something like that, or at least B is selected, A is not selected, something of this sort. So as we move
Hmm.
on to the problems, you'll be able to understand better, I think.
Yes. Yes. Good.
Okay, let's do that. Then we'll see. Okay, in a population of 10, so if a question like this comes, put more preference in C related answers
Yes.
instead
Yes.
of this thing. Okay,
Yes.
because this
B.
does
Yes.
happen, but maybe it's not correct to list it out like this. Okay,
Sample size is fixed, and each unit can only be
there is the
selected
key
once.
feature. Key
Hmm.
feature, if
Without
somebody asks, then each unit can be selected only once, then it
only
is
one. That
just
is
thrown away. Yes,
without replacement. Yes.
without replacement.
Hmm.
So question here, in a population of 10 individuals, you are drawing a sample of 3 individuals with replacement. What is the probability that a particular individual will be selected twice?
Three individuals.
Hmm. But probability individual
Individual is 1/10.
individual is selected is actually 1 by 10. Okay, and the
Hmm.
probability a particular individual is selected twice is how much?
Selected twice is. That will also remain 1/10 because it is with the replacement.
Yes, it's with replacement, so it should remain 1 by 10.
In a population of 10 individuals, we are drawing a sample of 3 individuals with replacement. Probability of a particular individual will be selected twice.
Okay, so at each go, an
Hmm.
individual, so I have this thing,
Three spaces, right?
3 spaces, right? So here the denominator is, I could have 10 people are competing for this spot, so I have
Hmm.
10 cube all possible samples. Okay, so
Hmm.
a particular sample is selected twice. So, or I would rather not do it this way, I'll do it some other way. 1 second. So here you see, at any go, probability an individual is selected is 1 by 10. So I am drawing a sample where I have 3 spots. So if probability of selecting a particular individual is twice, so then he selected twice, once in with probability 1 by 10,
1 by 10.
again with probability 1 by 10, and then the third
Okay.
individual that is selected, that could be selected in 9 out of 10 ways, because I am just selecting this individual twice. Is it okay?
This will be 9 by 10.
Oh, sorry. Did I write it correctly? It's if you are drawing a sample of 3 individuals with replacement, what is the probability that a particular individual will be selected twice? Sorry. So an individual selected twice is this
By 10.
probability.
1 by 10
I
into 1 by,
think.
that is 1 by 100.
Yeah,
No.
this there seems to be an issue with this
1
question.
by 100 selected.
Right now I'm also confused. So I think it will be 9 by 1000, but this should be 1000, I think. Okay, so let's move on. Here, in a population of 5 units, a sample of 3 units is drawn without replacement. What is the probability that a specific unit is not selected? So if a specific unit is not selected at each of the draws, how should we frame this? So I have 3 units, okay, and I have 5 spots. So when I'm selecting for the first time, I have all 5 units to select from. In the second one, I have 4 units to select from, and in the third one I have 3 units to select from. Okay, so here I am actually selecting 3 units out of 5. So if unit A is not to be selected, then it leaves me with 4 other points, let's say B, C, D, E, who will be competing for this position. So this is 4 by 5. Once I have one of them occupying this spot, then I have remaining 3 people competing for this spot. And then once I have that, then I would have 2 people to choose from 3. Okay, so then the final probability will be 2 by 5.
A 5 for not getting selected any specific unit.
Yes. So
What is the
first probability is probability of selecting A is 1 by 5.
Hmm.
But probability of not selecting A is 1 minus 1 by
4
5.
by 4
Here
by
is 4
5.
by 5. So that is for the first trial. In the next unit, what is happening? I have, so one is already selected. So from the entire pool, one is removed. Now I have probability of not choosing A. Of choosing A is 1 by 4. Of not choosing A is 1 minus 1 by 4.
3 by 4.
3 by 4. And then again, if I move on, 1 is chosen and that is thrown out. So now I have 3. So probability of choosing A is 1 by 3 in that case. But of not choosing A is 2 by 3. So, and since the units are independently drawn because it's a random sample, that's why this is the answer.
2 by 5.
2 by 5. Okay, moving on.
Yes. Yes.
In a population of 20 individuals, you are drawing a sample of 5 individuals without replacement. So, what is the probability that a particular individual is selected twice?
Let's see first. 1 by 20. And not is 19 by 20. And selecting him.
So, this is without replacement. So, I have 5 spots, let's say. And I just have a specific individual selected exactly twice. Okay, so if I am drawing a sample of 5 individuals without replacement, what is the probability that a specific individual is selected exactly twice? It's actually 0. Why? Because I am doing without replacement.
Without replacement, yes, 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 yes.
Okay.
So very, very simple.
Yes. So moving on. In a population of 15 individuals, you are drawing a sample of 4 individuals with replacement. What is the probability that a specific unit will be selected at least once?
Four individuals.
Yes. So, probability of it is selected at once. So, probability at least once selected equal to probability equal to 1 minus probability never selected. Do you agree with this point? Okay. So, probability it is never selected means I have 4 spots.
Mm.
Okay, all the time I have it's sampled with replacement. Okay,
Mm.
I have
So it will
15
be
contenders for
15.
this space, but I can
Mm.
only choose 14.
Mm.
Okay, so first position, that unit is not selected, probability 14 by 15. Second spot,
Mm.
that unit is not selected, again 14 by 15. Third, fourth, similarly. So the answer is 1 minus 14 by 15 whole to the power 4. That
4.
is A.
Mm.
Okay, next. A sample of 7 students is selected out of 30 students by SRSWR and SRSWR. What is the probability that 15 students will be selected? So here
Mm.
we are not talking about a sample and when this 15 student will be selected, nothing of that sort. We just want to know probability that 15 student will be selected. So that is the
Mm.
same for SRS and SRSWR and SRSWR. That is 7 by 30. Should be something close to 0.23. So it should be C. Okay.
Equal chances. Mm.
All right. This one. So in a coffee shop, there are 4 different types of coffee, 3 different cup sizes, and 3 possible add-ins. You randomly choose one coffee, one cup size, and some add-ins. Okay, what is the probability of ordering 2 cups of coffee with no add-in?
4 different types of coffee, 3 different cup sizes, and 3 possible add-ins. 1 by 4. Somebody ordered 2 cups of coffee with no add-ins. Selecting a specific type of coffee. 1 by 4 into 3 into 1 by 2. Types of coffee, 3 different cup sizes, and 3 possible add-ins. Choose one coffee, one cup size, and one add-ins. What is the probability of ordering 2 cups of coffee? 2 cups of coffee, 1 by 4, so 2 by 1 by 2. And then with no add-ins. Add-ins are 3 possible add-ins.
So what are the all possible options that you have? You could have
Mm.
4 types of coffee into
Mm.
3 types of cup sizes into 3 possible add-ins.
Mm.
Okay,
Mm.
so this is how much? This is 36, let's say.
Mm.
Now, let's say I randomly choose one coffee, one cup size, and some add-ins. Okay, here I am choosing add-ins, so I will remove this part. Okay, okay, one coffee, one cup size, and let's say one add-in. So
Mm.
I could have these many possible coffee choices. Okay, so out of
Mm.
first things first, probability of ordering a specific cup is actually I order one by any one out of the four. Where is it going? So I order any one of the four cups.
Mm.
I order any one of the three cup sizes,
Mm.
and I'm ordering one of the three add-ins, let's say. So
Mm.
this is a probability of ordering one cup. Okay, so it's something
Mm.
close to 1 by 36. So since it's not that if I order one cup of coffee in size small, I cannot order another cup, right? So if I have to order two of this, ordering cup 1 and cup 2, then for cup 2 also I will have same kind of choices. So the correct answer would be 1 by 36 square. Now how much should that come to?
9216. 30 is only 900, so
36 into,
36, 36 into
let's
36.
just do it here. 36 into 36
1296.
is 1296, sorry. Okay, so then
Mm.
this should be my coffee. But if the same thing I am saying that you can only order a certain type once,
Mm.
then it would change. So for the first cup I would have one, I could choose one out of four. For the second cup I could choose one out of three. Then again for milk, uh, I could choose, I mean, for different cup I had to choose 1 by 3 into 1 by 2. And then for cream again 1 by 3 into 1 by 2. So then this would have changed. You get my point?
Mm.
This is with or without
For the
replacement
first
stream.
cup, that is the question is, what is the probability of ordering 2 cups of coffee and selecting a specific type of coffee? Specific type of coffee does mean add-ins.
Yes, uh, this one. So specific type of coffee means this cup coffee
That
plus cup plus some
add-ins.
add-in.
So it is taking 2 cups of coffee. So 2 cups of coffee. First is 1/4. Okay, and then we'll have 1/3. That is okay without replacement.
For
Then
the second
one
cup
by
also same thing.
and 1/2, and then 1/3 and 1/2. Mm. For the second cup also. 1/12, 1/6, 1/6, 36.
Okay, another. So here there could be a possible confusion, because
Mm.
add-in is any combination of cream, milk or sugar.
Mm.
So all possible combinations of cream, milk and sugar is actually 3 factorial.
Mm.
So in that case, I would have 6 options for this thing. Okay, I could have cream, sugar, milk,
Mm.
cream sugar, cream milk, sugar
Mm.
milk. And then again, what let me just list it out. I could have cream, sugar, milk. I could have cream, sugar, cream milk or sugar milk. I could have none. Okay, now it makes sense. I could have none of
Mm.
the add-ins, and also I could have all three.
Mm.
1 2 3 4 5 6 7 8. Okay, not 6 factorial, I was incorrect. So here, let me just redo this thing entirely. I think I misunderstood this question.
Mm.
So let me just rephrase. So I have 4 choices of coffee.
Coffee.
I have 3
Three
choices of
choices of
cups,
cups.
and a combination of add-in
Mm.
where I have 3 elements. Any combination of cream, sugar or milk, and none.
Mm.
So if I select none, plus if I select just one, plus if I select two, plus if I select all. So this is actually 8 combinations in total.
Mm.
Okay, yes. So I could have 8 combinations of this thing. You randomly choose one coffee, one, and what is the probability of 2 cups of coffee? Initially question was with no add-ins and selecting a particular type of coffee. This was the initial question. So here I have all possible choices for me for one cup could be 1 out of 4 into 3 into 8 types of coffees combos that I could have.
Mm.
That is actually 1 by 96. Okay, and since cup 2 is also with replacement, cup 1 and cup 2 selection, that probability is also 1 by 96. So ordering 2 cups of coffee would be whatever I had previously written, 9216. Is it okay?
Mm.
This makes sense.
That also we can make out without having any combination.
Without having any combination is this one 3C0, where I'm not taking anything.
Mm.
This is only none. So this is also accounted for here. Here is this. Oh. So this one is none.
Mm.
Here I could have 3 possible choices: cream, sugar, milk. Here
Mm.
I could have cream, sugar, cream, milk, sugar, milk.
Mm.
And here I have all.
Mm.
So this is actually, if you expand it, it will come to 2 cube 8. This is 1 plus 3 plus 3 plus 1.
Mm.
So 8 combinations. So all possible types of coffee could be 8 different choices of combinations, 3 different choices of cups, and 4 different choices of coffee. So out of
Mm.
that, I'm selecting just one specific type of coffee. One of these combinations I'm selecting.
Mm.
So I'm sure latte has some components from here, like a particular type of coffee, particular combinations of sugar and cream, something of that sort.
Mm.
Okay, so this is the
Mm.
correct answer. I'm sorry for being for confusing you, but this is how you should tackle if such questions come. All right, moving on. So, in a deck of 52 cards, 5 cards are drawn with replacement.
Mm.
What is the probability that a specific card is drawn at least once in 5 draws? Same thing, at least once meaning probability none.
Mm.
So, none meaning out of 52, I have 51 of
51.
those options can come up into to the power 5, because I have drawn 5 draws.
5 times.
5
Five
times,
draws.
yes. Okay, moving on. A box contains 10 balls, 3 blue, 3 red, 4 blue, and 3 green. You randomly select 2 balls without replacement. What is the probability that you select 1 red and 1 blue ball?
10 balls, 3 red, 4 blue, 3 green. Okay, you randomly select 2 balls without replacement. This is probably that you select 1 red and 1 blue ball.
So, total I have 3 plus
3
4
red,
plus 3, 10
3.
balls.
Mm.
Okay, and I'm drawing without replacement.
Mm.
So, first pot I could draw 10, and
And 3
second
red.
draw I could draw 9.
Mm.
Now let's say first ball I am drawing red and second ball I am drawing blue. So then for
Mm.
drawing red balls I have 3 options.
Mm.
For drawing blue balls I have 4 options. So it's 12
Mm.
by 90. Okay. Now let's say I draw
First blue,
first blue
then
and then red.
4 and then
Then also I have 4 into 3
3.
by 10 into 9, 12 by 90. So then if we, the total probability is adding these two up. So it will be 24 by 90, 8 by 30, 4 by 15.
50.
Okay,
Mm.
next. So now the question is, a box contains 10 balls, 3 red, 4 blue, 3 green. You randomly select 2 balls with replacement. What is the probability that you select 1 red and 1 blue ball? Same thing,
Mm.
selecting 2 balls with replacement. So here denominator remains unchanged. Here also I could select 10, here also I could select 10.
Mm.
So if I have red
3 red
and
1.
blue, then 4
Mm.
into 3, and blue and red is also 4 into 3 by 100. So if we add these two up, we'll have 24 by 100, so which is 4, 6 by 25.
6 by 25. Mm.
Okay, moving on. A box contains 15 balls, 5 red, 5 blue, 5 green. You select 3 balls with replacement. What is the probability you select 2 red balls and 1 blue balls? 3 possible, 15 balls with replacement. So 15, 15, 15. 2 red balls and 1 blue ball. So I could have red, red, blue,
Red, blue, red.
blue, red, red, all sorts of combinations.
Mm.
Blue, red, red, then
Mm.
red, blue, red.
Mm. Blue, red, blue. नहीं, एक ही red, एक ही blue. One,
Hmm.
only one blue.
And
Right.
these are like indistinguishable. So only one blue, blue can occupy these three positions. So
Mm.
I would have 3 into probability of 2 red balls. So red is 5 by 15, again 5 by 15, and 1 blue ball. This is again 5 by 15.
5 by 15.
So this will be 1 by 3, 1 by 3, 1 by 3. So answer is 1 by 9. Okay.
Yes.
Now, had these red balls been distinguishable, then we would have had some more combinations. But for now, we'll consider that this red and this red are not different, they are same.
Mm.
Okay, but if one is a crooked red and one is a
Mm.
smooth red, then again it uh, could have made a little difference if the order mattered. If order here particularly order is not mattering because I'm just drawing red balls. Okay,
Mm.
but I don't think such problems will come right away, but just giving you a brief. Okay, the last question for the day. The 52 cards in a shuffle deck are dealt with equally among 4 players. Call them A, B, C, and D. If A and B have exactly 7 spades, what is the possibility that C has exactly 4 spades? Okay, so A,
Mm.
B, C, D. 52 cards, so each is going to have 13, 13, 13, 13.
Mm.
Okay, now A and B have exactly 7 spades. So A has 13 cards, out of which exactly 7 are spades.
Mm.
B also has 13 cards, out of which exactly 7 are spades. So C
Mm.
uh, needs to have exactly 4 spades. So how many spades are there in the
13, no?
in the that
5.
is 13. Okay, so total number of spades is 13, out of which A and B have 7. So the remaining that C could have is 6.
Mm.
Okay, and this 6, so out of this 6, C has
6
to
is.
choose exactly 4. So
Mm.
the numerator would be 6 choose 4, but what will be the denominator?
7,
So
13,
6 choose
yeah,
4,
7, 6.
4 spades, C will have 4 spades, but
Mm.
13 minus 4, 9 cards he should have, C should have from the remaining cards.
Mm.
So remaining, how many cards remain? If I have 13 spades, we have already decided on the fate of these 13 spades. So remaining number of cards is actually 39.
39. Mm.
So C should have 39 9, and denominator would be 7 spades already decided. So 52 minus 7, whatever it is, that is 565, sorry 45.
Mm.
So denominator is from that 45, C will get 13 cards, and this is the answer.
Mm.
7
See.
spades already decided, and we
Mm.
have 52 cards.
Mm.
So denominator would be total number of cards that C has to receive. So C can choose 45 uh, 13 cards from 45
Mm.
cards. That is the denominator. Okay, that is the number of, that is the what should I say, number of ways C can have a hand. Okay, now the probability is what type. So in order to have exactly 4 spades out of remaining 6 spades, C should choose 4 spades in 6c4 manner. And what about the remaining 9 that has to come? That should come from the remaining 39 cards. Okay, so whatever
Mm.
this is the answer. All right, so
Yes.
I'm going to close today's session, but if you have
Mm.
anything you can ask me.
I will try to. These questions will be available with me, or
Pardon?
the questions which we are solving. These questions will be available to me.
Yes, this should be relevant to you. Uh,
Will they be available on the site on the group?
the available. Oh,
Yes.
okay. So the slides and this recording will be available on YouTube, and the slides will be available on the Google Doc folder. That have you ever looked here? See,
Yes, yes. The first and second, I have seen it.
yes.
The
So if
probability
you
solving sessions here.
yes, so
Problem solving
if you
session.
go to this thing, the one Google Sheet is supposed to open up,
Yes.
and that will
So
have the
this will be.
links to all the folders. Yes, the
Okay.
recording and the slides will be shared here. And you could just take up any textbook to solve these issues, and we can
Questions.
discuss if necessary.
Thank you.
Okay, thank you so much for joining. And in the next session, before moving on to week 4, I would do a small hands on how to carry out this sampling with R, which we did not have the time to discuss today. But I'll keep that for
Yes.
the next session, and then we'll take it from there.
When is the next session?
Again, next Saturday, 7 to 9.
Thank you very much, ma'am.
Okay. Thank you so much, sir, for joining. Have a good night. Bye bye.